Welcome to Understand the Math. In this video, I'm going to teach you everything that you need to know about parallel and perpendicular lines. We'll start by learning what the slope of parallel and perpendicular lines look like, and then we'll walk through example problems where we'll find the equation of a line parallel to a given line and an equation of a line perpendicular to a given line. And then we'll look at some problems where we'll determine if two lines are parallel, perpendicular, or neither. Let's get started. We'll start by learning what the slope of parallel and perpendicular lines look like. Two lines are parallel if they have the same slope. In this graph, I have two lines and they each have a slope of 2. Remember that the slope is equal to the rise, which is the change in y, divided by the run, which is the change in x. When two lines have the same slope, we write that M1 is equal to M2. Let's now look at two lines that are perpendicular. In this graph, I have one line that has a slope of 2, and then the other line has a slope of -1/2. These two slopes are what we call negative reciprocals of each other. And we notate this by saying that M1 is equal to -1 over M2. When two lines are perpendicular, the rise and run are flipped, and one of them has a negative. Let's now walk through some examples where we're going to find the equation of a line that is parallel to a given line. In our first example, we want to find an equation of the line through the point 1, 2. I have this point marked down in our graph right here. And we want this equation to be parallel to the line 2x minus y is equal to 3, and that's the line I have graphed in blue. I wrote down some steps that will help us walk through this problem. Our first step is to find the slope of the line that's going to go through the point 1, 2, and I called this slope M2. To do this, we first have to find the slope of the line that we're given. So let's write down the equation of that line. It's 2x minus y is equal to 3, and we need to find the slope, so we need to put our equation in the form y is equal to mx plus b. So let's go ahead and let's do that. I'm going to take the 2x and I'm going to move it to the right, so we have a minus y is equal to minus 2x plus 3, and then let's divide by -1 to get y by itself. So we have y is equal to 2x minus 3. So that tells us that our slope, which I'm going to call M1, is equal to 2. Now we need to find the slope of the line parallel to this line. When two lines are parallel, they're going to have the same slope. So that tells us that M2 is going to equal 2. Now what we need to do is find the equation of this new line. So we're going to start with the point slope form of the equation because we know the slope and we know that it passes through the point 1, 2. The point slope form of an equation looks like this. It's y minus y1 is equal to m times x minus x1. Our x1 comma y1 is our point that we're given, which is 1, 2, and we just found our slope, which is our m2, is equal to 2. Now let's go ahead and let's plug this in. So we have y minus y1, which is 2, is equal to our slope, which is 2, times x minus x1, which is 1. Let's multiply everything out, and we'll move the 2 that's on the left to the right. So we have y is equal to 2x minus 2 plus 2. So that tells us that our equation for our line is y is equal to 2x. I'm going to go ahead and draw that so we can get a conceptual feel of what this looks like. And there's our line. Notice that our two lines are parallel and that they have the same slope. Let's now look at another example. You may want to pause the video and see if you can do this example on your own. This example is just like our previous example. We're going to find an equation of the line through the point 1 minus 6, and this line is going to be parallel to the line x plus 2y is equal to 6. I've written down the same steps that we had on the previous page that we can follow. The first step is we're going to find the slope of the equation of the line that we want to find. So we're going to begin with the equation that we're given, x plus 2y is equal to 6, and we're going to find the slope of this equation. So let's keep our y on the left, and we'll move our x to the right, so we get a minus x plus 6. Now we're going to get y by itself, so we're going to divide each side by 2, and we have minus 1/2 x plus 3. This tells us that the slope of our line, which we're going to call m1, is equal to minus 1/2. And because our two lines are parallel, this is going to be the slope of our new line, which we're going to call m2. We're going to begin by the point slope form. Y minus y1 is equal to m x minus x1. And then let's write down what our x1, y1 is. x1, y1 is the point that we're given. Let's pull that back down. It's the point 1 minus 6. And our slope is our m2 slope that we just found, and that's minus 1/2. We're going to have y minus y1, which is minus 6, so we got to be careful with our negatives, is equal to our slope minus 1/2 times x minus x1, which is 1. This gives us y plus 6, and let's multiply everything out on the right, is minus 1/2 x plus 1/2. Let's now take the 6 to the right, so we have y is equal to minus 1/2 x plus 1/2 minus 6. We can think of our minus 6 as minus 12 divided by 2. That'll make it easier to add our fractions. And so we end up with an equation y is equal to minus 1/2 x, and we have a 1/2 and a minus 12 halves, so that gives us a minus 11 over 2 for our final answer. And that's the equation of our line that's parallel to the line x plus 2y is equal to 6. Let's now look at some examples where we're going to find the equation of a line perpendicular to a given line. In our first example, we're going to find the equation of the line through the point 1, 2 that is perpendicular to the line 2x minus y is equal to 3. The point and the line are both graphed here on the right. We're going to follow the same steps that we did when we found the equation of a line parallel to a given line. Our first step is to find the slope of the line that we want to find. So we're going to begin by finding the slope of the line that we're given. So let's write down that line. It's 2x minus y is equal to 3. We want to find the slope, so let's get y on the left and everything else on the right. This gives us a minus y is equal to minus 2x plus 3, and then we'll divide by negative 1, and we have y is equal to 2x minus 3. So that tells us that the slope of our line, we're going to call it m1, is equal to 2. Now, if two lines are perpendicular, their slopes are negative reciprocals of each other. So we say that m2 is equal to minus 1 over m1. And if we plug in m1 as 2, this gives us a slope of minus 1/2. Now we can go on to our next step, and that's to find the equation of the line through the point 1, 2 with the slope minus 1/2. We'll begin with the point slope form because we have a point and we have a slope. So that's y minus y1 is equal to m x minus x1. And let's write down that our x1, y1, now I have to pull it back down. That's the point 1, 2. And then our slope is equal to minus 1/2. Now we just have to plug in. We have y minus 2 is equal to minus 1/2, x minus x1, which is 1. Let's go ahead and let's multiply out the right-hand side. So we have y minus 2 is equal to minus 1/2 x plus 1/2. Be real careful with that negative. Now we're going to bring the 2 to the right-hand side. So we have y is equal to minus 1/2 x plus 1/2 plus 2. And we can think of our 2 as 4 over 2 so that we can add our fractions a little bit better. And this is going to give us the equation y is equal to minus 1/2 x. And we have 1/2 plus 4/2, which is 5/2. So we add 5/2. And that is the equation of our line perpendicular to our given line and going through the point 1, 2. Let's go ahead and graph this so that you can see what it looks like. Now you can see on our graph that our lines are indeed perpendicular. Let's now look at our second example. You might want to pause the video and see if you can do this problem on your own. We're going to follow the same steps that we did for the first example. So we're going to begin by finding the slope. We're going to start with our first equation and find the slope of that. So that's 3x plus y is equal to 4. Solving for y, we have y is equal to minus 3x plus 4. So that tells us our slope, I'm going to label it m1 because that's the slope of our first line, is equal to minus 3. And we know that m2 is equal to minus 1 over m1. So our m2 is going to be equal to minus 1 over minus 3, which is going to be equal to 1/3. Now we can go on to our second step. Our second step, we're going to begin by using the point slope form. So we have y minus y1 is equal to mx minus x1. And let's write down what x1, y1 is. So x1, y1, if we go back up to our problem, we can see that it's the point minus 2, 2. So we'll write minus 2, comma 2. And our slope is the one that we just found, m2, and it's equal to 1/3. Now all we have to do is plug in. So we have y minus 2 is equal to 1/3 x. Now we have to be careful with the negatives. We have x minus a negative 2. So this is y minus 2 is 1/3 x plus 2. Let's see if we can squish it all in here. Let's go ahead and let's multiply this out. So we have y minus 2 is equal to 1/3 x plus 2/3. And let's go ahead and let's take our 2 to the right. So we have y is equal to 1/3 x plus 2/3 plus 2. Let's think of this 2 as being 6 over 3. So we end up with a final equation, y is equal to 1/3 x, and then we have 2/3 plus 6/3, and that gives us 8/3. And that's the equation of the line that is perpendicular to the line 3x plus y is equal to 4 that passes through the point minus 2, 2. Let's now look at some examples where we're going to be given two lines and asked to determine if they are parallel, perpendicular, or neither. We're going to walk through 3 examples. Here's our first example. We're given the equation of 2 lines, and we want to find if they're parallel, perpendicular, or neither. I've written down some steps that we can follow just to make it easier. The first step is that we're going to find the slope of each line, and then we're going to compare the slopes and see if they're equal, if they're negative reciprocals of each other, or neither of those. Let's begin with our first equation, y is equal to 2x plus 3. We can see really easily that the slope of this line, and I'm going to call that slope m1, is equal to 2. Now let's look at our second equation. Our second equation is 2y minus 4x is equal to 5. We need to solve for y to find the slope. So we have 2y is equal to 4x plus 5, moving the 4x to the right. Now we're going to divide each side by 2, and we get y is equal to 2x plus 5/2. And that tells us that our slope, which I'm going to call M2 because it's our second line, is equal to 2. That's just the constant that's multiplying x. Notice that our two slopes are the same, and because the two slopes are the same, we can conclude that the lines are parallel. Let's now look at our second example. We're going to do the same thing. We're going to start with our first equation and find the slope. I'm going to write down the first equation. We have minus 3x plus 4y is equal to 4. We're going to solve for y, so let's bring the 3x to the right. So we have 4y is equal to 3x plus 4. Now we're going to divide by 4, and we'll get y is equal to 3/4 x plus 1. So that tells us that our slope of our first line, M1, is going to be 3/4. Now let's look at our second line. That's 4x plus 3y is equal to 5. We're going to solve for y, so we have a 3y on the left, and we take our 4x to the right, and it becomes a minus 4x plus 5. Now we'll divide each side by 3, and we have a minus 4/3 x plus 5/3. So that tells us the slope of our second line, M2, is equal to minus 4/3. Now we're going to compare these two slopes. Notice that they are reciprocals of each other and they're negative of each other. So this tells us that our slopes are negative reciprocals of each other. So our lines are perpendicular. And the reason for that is our second slope is minus 1 divided by our first slope. Let's now look at our last example. You might want to pause the video and see if you can do this one on your own. We're going to start with our first equation. 7x minus 3y is equal to 2. We're going to solve for y, so let's pull the x to the right. That gives us a minus 3y is minus 7x plus 2. Now let's divide each side by minus 3. We have then y is equal to 7/3. Notice that the negatives cancel. X minus 2/3. So the slope of our first line is equal to 7/3. Now let's look at our second equation. We have 21x plus 9y is equal to 1. We're going to solve for y, so we have 9y is equal to minus 21x plus 1. We're going to divide both sides by 9, and we get y is equal to minus 21/9x plus 1/9. Let's notice that 21 and 9 are both divisible by 3, so let's divide both of them by 3, and we get a minus 7/3x plus 1/9. This tells us that our slope, which we're going to call M2, it's the slope of our second equation, is equal to minus 7/3. Now we're going to look at these two slopes and we're going to compare them. The two slopes are negative of each other, so we can say that M1 is equal to minus M2. However, they're not reciprocals of each other. So this tells us that our lines are not perpendicular and they're not parallel. So we can conclude that our lines are what we call neither parallel or perpendicular. And that's it. You now know how to identify and write equations for parallel and perpendicular lines.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.